Hi, my name's Rob Pope, Senior Consultant and Partner with Ecolite and Energy Solutions, and it's my pleasure to present on behalf of the Regional District of Okanagan-Similkameen this first of a six-part series on the subject of best practices in building planning design, compliance, best practices in building envelope, and high-performance HVAC systems. Today we're going to introduce and explore strategies for building an energy-efficient home. Other chapters in this series will include Energy Step Code, Zero Carbon Step Code, and Regulatory Compliance, followed by Working with Energy Advisors, then Building Envelopes, and we'll have a chapter on heating, cooling, and ventilation, and finally, Working with your builder. When building a high-performance building, it's really important to take a holistic approach and consider that the building itself, with its walls, windows, how leaky or airtight it is, and the mechanical equipment in it are all components of one whole system that, when combined, create the performance and energy efficiency of the home. There are many reasons to build a high-performance home, but let's just look at a few of the benefits. Lower utility bills. Of course, lower energy consumption reduces your operating costs and does give you a hedge over future increases in energy prices. Healthier living. Your indoor air quality becomes healthier by design and includes mechanical ventilation and air filtration that you can control. Greater comfort. In a high performance home, you're not going to have short cycling of your heating equipment. You're not going to have a drafty home, and temperatures will be even, constant, and more controllable. Reduced pollution and CO2 emissions. Reduced energy use will significantly lower greenhouse gas emissions. Potentially increased resale value. High performance homes can typically sell more quickly for more money than conventional homes in the same market. And finally, reduced noise levels. Increase the quality of the windows, triple versus double pane, for example. More insulation in the walls, smaller mechanical systems. These will reduce sound transmission within the house and from outside, like traffic noise. It's a more quiet living environment. The home building industry in this country, especially BC, is going through a major transition right now that we haven't seen since the energy crisis of the 1970s. And there's a number of reasons for this. One is regulation, another is climate change, advances in technology is another, and consumer demand. In the regulatory environment, performance-based codes are here now. The new national model codes also introduce an incremental approach of tiered code systems, like the Energy Step Code here in BC, to achieve better building energy efficiency through a series of performance-based steps. Houses have to meet the code performance requirements. Climate change is a priority for all levels of government, national, provincial, and local. On the regional or local level, municipalities and regional districts are using quite a variety of policies and tools to achieve GHG reduction targets, with a priority on HVAC mechanical systems. Compliance and verification is evolving pretty quickly. Provinces and municipalities are all taking different approaches with HVAC. Different regulatory processes vary from minimum enforcement under existing building permits to more sophisticated approaches that include, in some municipalities, HVAC permits, for example, requiring load calculations, equipment selection procedures, and HVAC design and commissioning. New HVAC technologies are becoming more readily adopted. This is dynamically changing the HVAC industry, including new equipment, renewables, and smart controls. But one of the biggest game changers in new technologies is probably the cold climate heat pump. Heat pumps can now heat homes deep into sub-zero winter temperatures, making them an appropriate choice for any climate zone in this country. Consumers are more sophisticated in their buying decisions and interested in the benefits of high-performing energy-efficient homes. With rising costs of energy, climate change, and the simple expectation of better comfort and a healthier indoor environment, consumers are driving market change, forcing the industry to adapt to and meet those evolving expectations. Consumers have access to seemingly unlimited information through the internet. This is a two-edged sword. On the one hand, access to information empowers the consumer, but on the other hand, it can overwhelm the consumer with conflicting and often inaccurate information. In most cases, it's just enough information to make them dangerous. Nevertheless, they are better informed about their choices than any other time in the building industry. When we think about energy use in a home, we can see that the largest portion of use comes from space heating and cooling, bigger than domestic hot water, appliances, and lighting combined. There's a few things we can do to reduce the energy used by hot water, appliances, and lighting. But that 60% of energy use dedicated to your space heating and cooling is directly related to the performance level of your home. The higher the performance of your building, meaning walls, windows, air tightness, etc., and the better the efficiency of your HVAC system, the lower that percentage of your space heating and cooling. We've been talking a lot about high performance homes, so let's just be clear what that means. What is a high performance home? First, we have to compare it to a low performance home, which would have higher thermal transmittance, meaning heat moves faster through the walls. High air leakage, in other words, drafty and uneven temperatures, and a corresponding increase in energy use and cost. A high-performance home, in contrast, has low thermal transmission. Heat doesn't move so quickly through the walls, and so you don't lose so much of it. Low air leakage, meaning built nice and tight to remove drafts, keeping temperatures constant and even, and improving indoor air quality. All this reduces your energy usage and utility bills. House as a system. As mentioned earlier, we have to think of high-performance homes holistically. Although separate from each other, insulation, heating and cooling systems, windows, doors, ventilation, exterior walls, foundation, and even siding makes a house operate as a multi-component system where all the components are interactive, interdependent, and interrelated. Changing one variable affects another. What are some of the strategies for high performance? Now let's look at them generally and we'll go into further details in the upcoming slides. One is form factor and articulation. Another is orientation, balancing solar gains, for example, and shading. Enclosure first, passive approach, air tightness, house as a system, and interaction of enclosure and HVAC. And finally, integration of high efficiency mechanical systems. Form factor and articulation. Keep the geometry of the building as simple as you can. Obviously, a square box is more efficient than a complex design. The more corners there are, the more windows there are, the more exposed walls there are, the harder it is to achieve high performance. It can still be accomplished, it's just harder. Orientation, balancing solar gains and shading. Now we're getting much better at building homes that keep the heat in the house where we want it. So what we need to do is avoid overexposure of solar gains through glazing by using overhangs and glass with sufficient solar filtering. That filtering in the glass is referred to, as you can see here, as the solar heat gain coefficient. That's what the SHGC stands for. Closure first, passive approach. Now when we say passive, what we mean is the non-mechanical parts and components of the building. A well-insulated house relies less on the HVAC system. A better envelope is passive, requiring less care, less maintenance. There's less moving parts, things that don't have to be replaced and maintained, not like your HVAC system. Air tightness. An airtight home removes drafts and improves comfort and energy efficiency. Remember, low performance homes tend to be drafty, cold air and air you're trying to heat is coming and going. House as a system and interaction of enclosure and HVAC. As I've stated earlier, there is a direct relationship between the performance of the building and the requirements of the HVAC system. The higher the performance of the building, the smaller the size and cost of the HVAC and better the comfort it will provide. Integration of high efficiency mechanical systems. Selection of HVAC equipment and how the heating, cooling, and ventilation is distributed through a high performance home requires an integrated design process to optimize efficiency, aesthetics, and budget. And that brings us to the end of the first chapter, Introduction and Strategies for Building an Energy Efficient Home. Remember, this is the first of 6 in this series covering best practices in building planning design, compliance, best practices in building envelope, and high performance HVAC systems. And just to remind you, other chapters in this series will include Energy Step Code, Zero Carbon Step Code, and regulatory compliance, working with energy advisors, building envelopes, heating, cooling, and ventilation, and finally, working with your builder. Thank you very much for your time.